Okay, we are going to go ahead and get started. Those links that are on our front page here for while you were waiting, Laura's going to drop those in the chat here in a couple of minutes once more people join, so they don't miss out on those. So before we get started today, we will obviously welcome to the SAS Viya Transition Topics office hours. We are going to go over just a couple of administrative items before we get started. So please remember to stay on mute to minimize interruptions. Please use the Zoom chat feature to ask questions related to the office hours topics. Team members will be answering questions using the Zoom chat and verbally throughout the session. We do ask that you use that chat feature though, rather than asking your questions verbally, so we have record of them all. So if we don't get to one or we need clarification on one and to get back to you later, we can do that. And then also all questions will be published to our Q&A in portal after the fact, which is our next bullet. So answers for all topic related questions received throughout the office hours will be posted after the meeting concludes. And then all meeting materials, including the recording, will be made available in the CCSQ DNA portal after our event. We do ask that you just give us a few days to turn that around, given that we have to 508 our video recording and make sure any questions that were not answered or need more clarification, we can track those answers down for you. So with that, I am going to turn things over to Colton here in a minute. He is going to be presenting today on creating Excel and other report file types. And so Colton, I will pass it over to you now and stop screen sharing.
Thank you. Okay, can you see my screen here?
Yep, looks good.
Okay, so in this presentation, we'll focus on how to leverage Databricks, primarily Python, to modernize and enhance your reporting capabilities. Transitioning from SAS-based reporting to Databricks opens up a platform that's going to offer greater flexibility, scalability, and some more dynamic capabilities for reporting. So this presentation will give you, hopefully it'll give you the skills and tools to take advantage of these benefits while maintaining the core reporting functionality you're used to in SAS. So with that being said, let's take a closer look at some of the goals we want to achieve in this session, followed by why mastering these techniques is going to be worth your time. So the presentation goals, we're going to learn how to create dynamic and macro like reports using Databricks widgets. You'll understand how to generate Excel reports directly from Databricks, either using a template to maintain that formatting or from scratch. We'll develop a couple QA reports and kind of show you how you would go about doing that so you ensure data consistency and accuracy. And then we'll give some insights on, or we'll give some alternatives to some of those traditional SAS reporting methods using PySpark. So it's pretty simple. It's pretty simple why this is going to be worth your time. It's going to help you transition your SAS reporting code into Databricks. So let's go ahead and get started here. We're going to start taking a look at the reporting with the Databricks widgets here. And I'm going to go ahead and run it so the data is going to be available for us once we get to that point. So the Databricks widgets enable users to adjust parameters to custom and rerun reports without changing their code. This could be a solution for programs that currently run on macro variables. And Databricks widgets can be used for several things, but for today, we're going to kind of focus on reporting. What you need to know, so there are 4 widget types. There's a text where you can input a value. So you could input for the house. In this example, I'm using the house housing or Ames housing data set, and we'll get to that in a little bit. You can do a drop down. which is going to just show you, the different options there. You can use a combo box, which is going to, you can enter or you can select, or you can use a multi-select, which is going to let you select multiple values there. So those are the different widget types. You can kind of change the behavior based on the value selection. So you can have it, so every time you change a value, you can have it run the whole notebook. The default's going to be run the access command, and that's going to be kind of where the get values widgets, what the get value or the retrieve widget values, whatever cell that's in, that's going to be what runs. Or you can make it default, and you can change these values using here, and you just change the value if you'd want to there. The general process for Databricks widget for reporting is going to be to pull that data in, create the widget, retrieve those widget values, filter the data frame based on the widget values, and then you can calculate summary stats, and then you could go ahead and output that report to S3 or CDR. And kind of more information, you can go to the Databricks widget documentation here. I'm going to kind of go through this code pretty quickly so we can get to some of the Excel examples. But this is going to kind of give you kind of the workflow of what's going on. So we we pull the data in here. We create the widgets right here. You can also create widgets going up to this edit tab and then down to this add parameter, and then putting in the different values there. I like to have my widgets kind of as a default, so they're not picking anything. But if you run the report, it's going to show the entire data set until you start to filter. So that's kind of what you're seeing as you look into some of these. And then you can see the different types, the text, the combo box, the drop down, the multi-select. You can kind of see those, how they're created there. This is going to be kind of the main cell. This is what's going to be run every time, because I have it selected on that run access commands. So it's going to run this cell every time I change a value here. So you don't necessarily want it to, run the whole notebook every time if you can fix that. So I would recommend using the default value. It's going to retrieve those widget values and then just filter that data set, that data or query that you built in. And then this is going to kind of compute the summary stats, which I think is nice. And then it's also another good thing to include would be to kind of add those filter values when you're displaying your output. And I think something like this could be used in kind of your email. When you send the report over, you could include, you could just copy and paste whatever you print here into that email, so you don't have to try to calculate it every time. So this is kind of what's showing up. So this is hooked onto a query, and you could build it on more complex query. I'm just building this on a select all of that Ames housing data set, and it's showing the filter details. And like I said before, you could kind of come up with different summary stats, etc., for what you want to include when you filter this. So we could filter it to 200,000, and then it'll just go ahead and run. And you could, have it on one or two You could go and filter it with whatever values you want. So this is kind of an example using that Ames housing with the different types or the widget types, and then you could, once you kind of have your report there, you could go ahead and filter that out to Excel. And kind of bringing this back to kind of our environment. So we've done a lot of deliverables in the past. So the way I would do this with some of those deliverables is I would make it I would put the measures in one of these multi-select. I'd put the measures here, and then I would also put like the reporting period, bring in that reporting value, and then you could just have it for 2024 reporting on measure one, or whatever measures you're using. So that's kind of how I would use that in this environment. And then when you're sending that deliverable out, just attach those summary stats along to help your stakeholder there. So that's a little bit about the Databricks widget, or reporting with Databricks widget. We're going to go on to reporting with Excel here. So a few common packages, or a few common Python Excel packages we're going to talk about today are Pandas, OpenPyXL, and then the Excel SX writer. So Pandas is going to be good for kind of those simple read and write operations to Excel. Think those read to Excel or to Excel. So kind of the basic, and obviously it's going to be good. It's going to integrate very well with Pandas data frames, because it is Pandas. Kind of if you're going to use a template, OpenPyXL is going to be very good at kind of preserving those formats and handling formulas and charts. It's going to offer more formatting and formulas and charts. The con's going to be, it's going to be a little more complex than using Pandas. If you're going to be building an Excel report from scratch, the Excel SX writer is going to be very good, as it offers detailed formatting, customized reports, and high-level control. One of the downsides of Excel SX writers is it's going to, you're not going to be able to read or modify existing files. So that's kind of the major con about using that package. Some of the key functions Panda has, like I said before, it's going to have that read Excel function, and the to Excel function. Those are the main two I use from those, and then you can kind of come back and use this as kind of a cheat sheet along with that Pandas Excel documentation there. OpenPyXL, like I said before, you're going to use that usually with a template, and you can load that template using that load workbook function, create a sheet using that function, and then you can kind of go through different tabs and make a, say you want to make that second worksheet or that second sheet active, you would go ahead and use that. You'd use the sheet name or the sheet name dot, and then make it active. And then to accept, to write or go to a different tab or a different cell, you could go ahead and use that cell function. And then kind of when you're done, you make sure to save that file in both OpenPyXL as well as Excel Excel SX Writer. Sorry, that's a mouthful. Um, and then the OpenPyXL documentation is there. So if some of the, there's plenty of different functions available. Obviously, I didn't include them all there. Some of the key functions for Excel SX Writer. Like I said, you're going to use this usually when you're building Excel reports from scratch. So you can go ahead and create a new Excel workbook using the workbook function. You'll see you can write data using that write function, and we'll show you a couple examples on how to use that in just a little bit. And then there's different formatting, insert and chart, conditional formatting, and then at the end you'll want to save your file. So we're getting to kind of the examples section. So for this section, the Excel portion of the presentation, we're going to be using Pandas data frame. It's just some sample data. We got the department, the patient ID, visit date, cost, and then satisfaction score there. I'm going to try to split screen it here so we can actually see the what we're doing here. So the hospital. So this is going to be the report we're going to be creating from scratch. So the two packages we're going to be using to create this report here is we're going to be using Pandas, which is going to be doing some of the grouping and aggregating of data, the pivot table, some of the data handling, and then we're going to be using Excel SX Writer for basically everything else used for creating the Excel workbook, writing the data to Excel, creating the charts, and doing the formatting. So we're going to go ahead and create the workbook here. We'll call it that hospital performance report. Then we're going to go ahead and create this tab here. We're going to set some formats that we're going to use throughout the spreadsheet here. And then we'll go ahead and write the title here. We'll write the title A1 through E1 there. Specifying if you're doing your report, you'd put in whatever title you'd want. And then we format that with the title that we specified above here. Then we're going to go down and we're going to write the headers. And we're just kind of iterating through the headers here. So as you see them on the thing, we're going to start with department, and then we'll just work our way through them. We'll do some more kind of a grouping and calculate some of the values that we're going to be using, like the counts, the total cost, the satisfaction score, and then we're going to go ahead and do an additional calculation, which is going to calculate the average cost per visit. And then we're finally getting to actually writing the data from the department summary data frame that we created up here with the aggregated values and the count and the total cost, etc. And then this write function is going to take on kind of that row and then the column and then the cell value, and then the formatting at the end. So one thing to note is these row and column values are going to start at index 0. So that's just something to note. So it's going to be 0, 1, 2, and then the values are going to start there. So for this first iteration of this, it's going to start at row 3 because that's what we specified with the index of 2. And then the index for the column values is going to start at that first column there. So it's just going to write this first row, or it's going to write row 3, column A through E there. And then as it iterates through, it's just going to add another column, and then or another row, and another row, and another row. And that's how the data is going to get into this report with this example here. We can also create a bar chart based on what we created here. So it's just going to, you're just going to specify which values you want it to create the report on. And then it's going to create this report. And you can give, the title, the category, the values, you can get crazy with it with the colors if you want to. And that's going to that's going to create this display here. And to actually place the chart in the Excel, you're going to specify this insert chart function, and then you'll go ahead and specify the cell that you want it to start in. So this one starts in G3. You could easily put it in G1 if you want them kind of back to back there. So that's kind of how to put a chart in there as well, with the data available. Another cool thing you could do is kind of add some conditional formatting to your Excel sheet here. So basically what's going on here is it's going to add conditional formatting. It's going to add this red color if the satisfaction score is less than 4. So we want to see if there's underperformers quickly. We don't want to have to eye every cell. So you add that conditional formatting and you'll be able to see that very quickly. And then we'll just go ahead and make the column lists 20 and 15 for the respective ones. So it looks halfway decent, and the values are not cut off. And that's kind of a look at this first sheet here on how we created that. This next tab here is going to create kind of that the data tab. And we're going to go ahead and create that worksheet, create those headers, and this time we're going to specify, gosh, why do I keep doing that? We're going to specify 0, so it's going to start at that row 1 position because it's indexed to 0, and then it's going to iterate through those column names and just spit them out. Boom, 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 boom. So that's going to write the headers here, and then this is going to actually write the data in a similar fashion to what we talked about earlier, this time starting in that row 2 position and shooting out kind of A through E, and then it's going to go down in the next iteration. It's going to shoot out that row 3, and then work its way across until it's gone through all the rows in that data frame there. And then you can go ahead and set the column widths again, so it looks nice. As you can kind of see, there's kind of a pattern here that we're kind of tracking to, where you're writing the headers in there, you're writing the data, and maybe you're formatting the data, or you're kind of setting the column widths there. This last portion here is going to create kind of like a pivot table-like view. It's going to add that worksheet. It's going to convert the visit dates to kind of a little better kind of, the month, year. So we can actually use that so we can group by the department and visit months there. And then, so yeah, we're going to use that to create the pivot table with the group by the group by variables being that department, and then the visit month, and then we're going to calculate different things like the total visits and the total cost and kind of the average satisfaction score by that department, and then the visit month there. Like I said before, it's kind of following that same pattern with the headers, the actual data, and then the formatting, and making those column lists so it looks halfway decent like we did in the other ones as well. You'll go ahead and save and close, and then you will, I didn't say this before, but so we created the Excel file here in this temp location. And then we're going to, after we're done and we save it, we're going to go ahead and copy that Excel to S3 using that copy function there. So another example, if you don't want to create your reports from scratch, or you want to kind of use kind of a template reporting, you could do a template reporting using this OpenPy Excel. And for this example, we're going to use, we're going to use this department scorecard template. And basically, we're going to be creating these scorecards for every department in our fake hospital, that our fake hospital. So we're looking at some of the similar metrics, but say you want to send this Excel document out to different department heads in the hospital so they can take a look at their data. So that's kind of what we're doing here. We're going to start with this department scorecard template. We're going to use the pandas and OpenPy Excel packages. We're going to use pandas, mostly used for the filtering, the calculating the metrics for each department, finding the unique list of departments. We're going to use the OpenPy Excel to load the template here, some styling, some sheet handling, column widths, and then we're going to use the name style function for some formatting. So this template here is already on my S3 location. So I'm going to bring that down to this temp location so that I can use the pandas pandas with it, and along with OpenPyXL. We're going to specify where that template is located, and it's going to be located right where we moved it, so that that temp location there. We go ahead and define the list of departments, or we find the list of departments. We create some styles for formatting, similarly to what we did with Excel SX Writer. And then we're going to go through and kind of create our different scorecards here. So we're going through each department in our department list there. We're filtering the data for each department. We're calculating the metrics. We're going to go ahead and load in that template. And then if you wanted to kind of create more of like a data tab, you could go ahead, if it didn't already exist, you could go ahead and create that. And then this is going to just write out the data headers to this data sheet here. And this is a little different syntax wise, because we're using that OpenPyXL package. So writing is going to be a little different in the writing in the different packages here. And then, so this next portion, I put a lot of comments in here. So if you guys want, or if you guys come back to it, you'll kind of understand what's going on. So it's iterating the different rows, kind of using the enumerate function, which is going to track kind of the index here. And I'm using that to represent the different Excel rows. And that's going to start at that 2 position here. And then it also is going to track a named tuple. The tuple, making these rows into a tuple is going to be nice, because we'll be able to access the column values using this kind of a row dot notation that you'll see here. So for the first iteration, the index value is going to be equal to 2, because we set it to 2 here. And then you'll see, or the tuple will look like this. It'll have the department, the patient, visit date, cost, satisfaction visit, and then it'll also have the index of the actual data set or data frame in there. So the first iteration is going to write to that row. This isn't the right one. It's going to write to this row 2 here, and then just make its way across, and kind of as it iterates through, it's just going to keep adding those rows on. So that's how the data is going to be put in using that OpenPyXL. So a way to kind of move from cell to cell, like I said before, is if you can use that active command. So here's an example of using that active command. So that's going to bring us back to this summary sheet, and then we're just going to go ahead and write those values in here. So B4 or B1 is going to be the department, B4, B5, you could write them wherever you specify in the values here. and then we'll go ahead and then create the style or formatting, or we'll go ahead and use that style or formatting that we created above. So it looks somewhat nice, and it has that currency for, B5 and B6, and then kind of that normal dot decimal for that B7 there. And then you can go ahead and set the column widths there as well. This is just a little different way to do it. You can using that for loop and kind of using the setting the ones in the second one, and then this is going to set the column widths in the first one here. And you'll go ahead and save that, and then you can go ahead, or you'll go ahead and save kind of each department scorecard, and then you can move each department scorecard over to S3. So this is an example of the cardiology scorecard that was created. I'm going to stop for questions. Do we have any questions?
We don't have any questions that haven't been answered yet.
Okay, great. So I'm going to move on to kind of the QA reports here. So for this section, we kind of rewrote some of our CMMI ETL QA reports that we use, and we rewrote them in Python here. Kind of a general overview of the code of what's gonna what I'm gonna show you is we create frequency data frames. So this is going to give kind of the frequency of each value within each variable. So for the example we're using, it's going to give each value for each variable in 2024 and 2023 data frames, calculating the counts and then the percentage distributions. It's going to go ahead and merge these two data frames so that we can go ahead and calculate kind of the percentage differences of those each values within the two data frames there. It's going to go ahead and kind of create a visual, which are going to be bar charts kind of for that quick inspection. And then also it's going to create an Excel spreadsheet with the actual differences and kind of all the values in one's spreadsheet, so you can kind of take a deeper look there. So the data frames we're going to be using for this section, we just have a couple small PySpark data frames. It's going to include the date, the category, the value, and then type. Those are the names. It's kind of generic, but I wanted to make sure you guys kind of could follow along with which type of variable we were working with there. And then there's also going to be a 2023 version. And I use PySpark data frames because that's probably what you'll output at the end of kind of your Excel or your data extract. So this first portion here is going to create those frequency data frames, and I created a function called create frequency df to do that. And we're going to import the functions. Why do I keep doing that? We're going to import the functions, import the functions function, and we're going to use for various functions to perform operations on the data frame. And then we're going to use that window function that Dan taught us about to generate those row numbers instead of using those raw dates for comparison. So kind of going through here, so we look at if it's a date or not a date because we're going to, let me see if I can. So that we can compare the first month's, so say we want to compare January of 2023 to January of 2024. So that's kind of how we're going to be doing that there. And we'll create those row numbers and iterate through. So January will represent 1, February will represent 2, kind of etc. for those date values there. We're going to go ahead and calculate. We'll go ahead and calculate how often the values occur, and then we'll calculate the percentage of the total for each variable there. For the non-date variables, we'll do the same thing without the initial part of making using the row using the row numbers instead of the actual values there. And then at the end, we'll go ahead and combine all the frequency data frame, or all the frequency data frames into that one there. And so that's just going to kind of build the function to go ahead and call. That's going to build the function, and then we're going to go ahead and call the function for 2023 and 2024 data frames. And you could go ahead and write this data frame to the CDR or S3, so next year you could compare data frames as well without having to rerun it. But the output is going to look like, it's going to show the different values here with how often they occur, and then the percent of total that they occur with for both data frames there. And then for this function here that we built, is going to basically compare the data frames there, and it's going to merge the frequency data frames. It's going to calculate the differences. It's going to generate the PDF that you see on the right here, and also it'll export the differences data frame to Excel, so you can take a deeper look as well there. So we're going to use several packages in this function here. We're going to import the matplotlib, use the pyplot, and that's going to generate those bar charts. We're also going to import the PDF pages function from the matplotlib, and that's going to create and save those plots to the PDF file. We'll use that pandas data frame. We'll use that Excel writer function, and that's going to write the comparison data frame to Excel. And then we'll do some more formatting with that OpenPyXL. And these last two are going to be used with the conditional formatting in the Excel, and we'll see that in a minute here. So the parameters of the compare data sets function, it's going to take a couple data frames. Type, you can, put in whatever type. This time, I think we use Benny as the type value, if I'm not mistaken. Let's see. Benny, and then you'll just go ahead and, use your current and previous year. So for this first portion, we're just going to rename some of the variables here, so we can kind of bring them. We're renaming them so we can do the merge. We'll go ahead and fill the missing values with 0. And then we'll go ahead and calculate the different percentages. And then if you wanted to return kind of this difference data frame, you could add in your return value here, and then that would return the data frame in the cell window here. For the actual graphing of these differences, we're going to bring it back to, we'll rename them back to the original values here, so we can kind of group them together. We'll go ahead and combine the data frames, and then we're going to find the different distinct values for the variables here, so that we can create a different plot for each variable here. We're going to specify where we want the PDF located. We'll use that PDF pages function, and the only place we're using that is kind of where you're going to save that figure here. So we're going to iterate through those variables, filtering that combined data frame on that actual variable, making it a pandas data frame so you can actually do the plotting there. And then we'll go ahead and specify kind of the values, the value for the index, the column, which is going to, if you use the columns equals run, which we created kind of up here in the rename section, you're going to be able to get those runs back to back so you can kind of compare the actual values there. And then this is going to specify that it's a bar chart and give the title, the X label, the Y label, the grid. And then this is, you're going to save the figure to that PDF, which you specified right here. The PDF, that's how you're going to save that figure to the actual PDF there. To actually create the Excel document here, we're going to specify that merge data frame that you could have, or I guess you'd want to, got a little ahead of myself. You'll want to specify the actual path of where you want it to be saved, and that's going to be in that temp. At the end, you'll move that over to S3. We're going to bring that merged data frame that was a PySpark data frame. You're going to move that to Pandas. And then we're going to use this Excel writer to go ahead and write that data frame to Excel. And we're going to use Excel writer so we can use some of the OpenPy Excel formatting features below here. So we go ahead and write the data frame to Excel, which is going to have it just all together there. I added some formatting there that's going to add kind of a blank row in between each variable, so you can kind of specify which variable you're actually looking at there. And then this piece here is going to go ahead and highlight if, so say the percentage difference is greater than 20%, or kind of what value you deem to be too much. You could go ahead and create that in your conditional formatting here, and specify that. And I think conditional formatting is very good with your report, so you can kind of see quickly what outliers you have there. So this conditional formatting is based on greater than 20%, or if it's there's a decrease of over 20%. And then this is just another way that you could specify the different widths there. So all these are 20 widths long, and then you can go ahead and copy that PDF in the Excel from the temp in Databricks here to where you'll go ahead and house them in S3 using that copy function. And looks like I got a couple minutes left. I'm gonna hopefully I'm gonna go pretty quick here. So this is an example of actually using the function with a couple parameters specified. This is that type name is going to be used at the bottom of the sheet, and then you'll just go ahead and compare these. I think these years are going to be used, I think, throughout, if I remember properly on how I did it there. And then you go ahead and write the data frames that you created to CDR S3 for future use as well. I'm going to run through this last section in a couple minutes, and then I'll be done. So for this last section here, we're going to be looking at alternatives to some of the SAS functionality using PySpark. This is going to be kind of a quick round. This is a very simple data frame using sales, quantity, and category. And so for this first example, it's kind of using the equivalent to that proc report or proc tabulate. It's just going to go ahead and summarize some data using that group by function, and then summing up sales and quantity. So there's an example of that. An example of some custom formatting, which would be equivalent to that format statement in proc report, would be to go ahead and use that format string. And for this example here, that format string is looking for that float value, so that's why we cast it to float. And then apply that dollar formatting there. An example of proc freak is just using that group by function paired with that count function, giving you that frequency table there. Another example of exporting reports, which would be equivalent to that ODS Excel, is just using that to Excel, just another example of showing that. And then you could go ahead, so you'll make that into that temp, the summary report here, and then you'll go ahead and copy that Excel file to S3. You could do a similar thing with ODS, which would be equivalent to ODS PDFs, creating that bar plot similarly to what we showed above, saving that plot, and then you could go ahead and then move that PDF to S3 there. Another example of conditional formatting, which would be equivalent to that kind of the ODS style or proc format, is kind of finding that maximum value within your Excel. And this is going to be kind of an example of doing that, and then go ahead and copying that Excel file to S3 after it's created. An example to that proc SG plot or proc G chart is kind of using that Seaborn package and creating a scatter plot here. And you can see the simple scatter plot that we created. And then we'll go ahead and save that to the temp and then kind of move that like we did everything else to S3. Some additional resources here. Here are the different files, or here are the different folders to the office hours, the data camps. And then there's plenty of documentation if you want to dig in on the Databricks widgets and the different packages that I talked about above. Another example of Excel reporting with Python. And then if you need a little bit more guidance on the Databricks utilities, you can go there as well. That is all I have for all the good reporting in Databricks here. Are there any questions? It looks like we got 3 minutes left.
We do need to administer our survey. Right now, Derek and Megan have been conversing in the chat, but other than that, there's no outstanding questions. So did you want me to go to the survey at this point, Colton?
Yeah, that's fine.
Okay. So you can feel free to drop once you submit the survey. This is just for us to make sure that we are gathering information and how we can improve our office hours experience. So I'm going to go ahead and launch that now. Thank you so much for joining today.